So today we're talking about solving polynomial functions. So this is what we did yesterday, correct? We were given a function and we graphed it. So what are the solutions to this function? Two, 3, it looks like 3, right? -2 and -3. A more accurate way to solve this polynomial function would be to factor. Okay, so that's what we're going to do today. All right, so pencils down. I'll give you plenty of time to write these out. We're going to do 4 examples, okay? All right. So there's always some type of clue, and I've kind of given you some clues over here. You've got your GCS, you've got squares, cubes, quadratics, grouping. What do you see in this one? There's no GCS. I see squares. If this was a perfect square trinomial, it would be what? X plus 6, and X plus 6 makes 12? Yeah, we're not there yet. So it's not a perfect square trinomial, even though there's a square there. But that's the first thing you should be seeing right there, is that you've got a square there. And there's actually a square here too. It's x squared squared minus, not yet. Okay, so I'm going to rewrite it this way. So I can't use GCS, I can't use squares, there's no cubes. Quadratics. Quadratics look like this. Is that in the form of a quadratic? It sure is. In fact, if you just cover these up, couldn't I factor it now? What two numbers, which I already heard it, 9 and 4? Both of them would be negative, right? And this would be x and x, which makes -9x, and -4x makes -13x. But it's not just x, right? They're x squared. Right? What else do you see? Difference of squares. This is now the difference of two squares right here, right? So x, and 3 and 3, and one's positive and one's negative, and x, and 2 and 2, and one's positive and one's negative. So what are my solutions? I could say plus or minus 3 and plus or minus 2, right? Is it or and? It's neither. It's just saying those are all the solutions. Plus, and isn't that what I have here? Plus 3, -3, plus 2, -2. Okay, go ahead and write that down. I should say x such that x is equal to positive or -2, comma, positive or -3. So let's look at this one. GCS, squares, cubes. Yeah. Cubes go up pretty quickly. So let's, what do you think this cube is going to be? Go through them in your head. What's 2 cubes? 8. And 3 cubes? And 4 cubes? And 5 cubes? 6 cubed would end with what? 6 times 6 is 36. And 6 times 6 is another, so we end with 6. So that's 7. 7. So this is actually x cubed plus 7 cubed. What do we call that? The sum of 2 cubes. You don't have to know your cubes to realize it's probably going to be a cube. So you put it in a calculator and you put 6 times 6 times 6. You know that 6 times 6 times 6 can't be it because 36 times 6, 6 times 6 is going to end in a 6. 7 times 7 is 49. 49 times 7, 9 times 7 is 63. Pretty sure that's it right there. That's how we did that. Nope, we're not done. So it's the sum of 2 cubes. What did we learn about the sum of 2 cubes? It can factor to a binomial and a trinomial. Right? Josiah? What would be the first one? X plus 7. And this would be an x squared. And this would be?
No, 7, 2,
49, right? Because 49 times 7 is 343. It's real easy because they're squares. They're all squares. You're taking cubes and breaking them into one binomial and one trinomial, and these are squares. So what goes here? Negative or positive? Negative, because they have to cancel each other out, right? Just like we did in that first exercise. And what's this going to be? Yep. Now we've got to solve for these. I can solve for this pretty easily. X plus 7 equals what? Uh-oh. X plus 7 equals 0, so x equals negative 7. There's one of my zeros. How's this one going to play out? Is it factorable? Probably not. It's not a perfect square. And it's not factorable. And I wouldn't use completing the square. Why? Because why? Because this is a 7. It's odd. Right? Perfect squares. Can I make a perfect square out of an odd? I can, but it turns into fractions, and it's not very, you use quadratic formula. Which is this lesson titled Quadratic Formula? You should already know how to do quadratic formula, right? So I'm not going to spend our time right now doing the quadratic formula. I'll tell you what this is. It's really pretty. You ready? 7 plus or minus I square root 147 over 2. So it has 2 imaginary roots. Go ahead and copy that down. All right, let's look at this one. All right, GCF. Is there a GCF? But before I go on and look and pull out that GCF, I need to also see if there's any type of squares or cubes or quadratics before I pull out. You guys aren't listening, right? Why would I say that? Right, you need to be cognitive of whether or not there's a GCF in there. But before you do it, because if I had something that was factorable and I pulled something out, a GCF out, I may not be able to factor it completely now. You know what I mean? So I need to look at it before I do it and say, is there anything else I could do with this? I've got squares. I've got, that's to the first power, second power, third power, first power. I don't see any rhyme or reason up there at all. right? Other than the fact that it's got a GCF. Let's pull out the GCF. What's the GCF?
2xy.
2xy. What's left over? 3xy minus y plus 3x squared. Can you do anything with that? Nope. That's factored. Copy that down. All right, let's do our last one. Here's number 4. What do you think? GCF?
No.
If you grouped it, you would have one. But then you'd have this one left over. Squares, cube, quadratics. There is a quadratic in there, but then you'd have the negative 12 left over. Sometimes you can group this and have that. Sometimes you can group this. Sometimes you can group the middle terms and the last two terms go together. There's lots of different ways to group, right? Here's the easiest way to do it. It takes all of the guessing out of the game. Your old friend, right? A cubed minus 4a squared. 3a negative 12. No guessing at all involved. What goes here? What goes here? What goes here? What goes here? There it is there. A minus 4 times a squared plus 3. Well, let's pretend that's the answer, but let's pretend like this said equals 0. Now what would I do with it? Then I'd have to solve. When I solve for this one, what do I get? Positive 4. When I solve for this one, what do I get? Almost. What did you say? I square root of 3. Not almost, almost. You're not. A squared equals negative 3. That's where he's getting that I from. Now what do I do? Take the square root. But when I take the square root of a quadratic, what do I get? Plus or minus I square root 3. Good job. Tonight you're not going to have to solve. Tonight you're just going to concentrate on factoring. You only have 10 problems to do. I didn't show you how to do 2 of them, but that's the give and take right now. I'm not going to make you do, what did I have originally? 14 through 35. You just have to do 1 through 8. They're just like I showed you, and then you're going to have to figure out 2 of them on your own by looking at the example in the book. Okay? This is grouping. Any more questions on this? I'd like to look at our homework now. Are we good? All right, excellent.